Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about the theory of attributes and the sampling distribution. Going ahead with the talk of the topic sampling, in this session, we are going to talk about test of significance. So, some terminologies are required before we get into the exact testing of significance of the population. Since for large n, almost all the distribution, example, binomial, Poisson, negative binomial, hypergeometric, chi-square, T, F can be approximated very closely by a normal distribution, and we use the normal test of significance for large samples. Hence, all the tests will be converted to standard normal variable by the formula Z is equal to T minus E of t divided by standard error of t. This we have discussed in the previous sessions regarding the sampling distribution. So, some of the well known tests of significance for studying such differences for small samples are t-test, f-test and Fisher's Z transformation. The technique of randomization used for selection of sample units makes us the test of significance valid for us. Before we step into studying the test of significance, some terminologies are required. What are the terminologies? The first terminology is hypothesis. What is meant by hypothesis? For applying the test of significance, first of all, we have to set up an assumption about inference of the whole testing. So, for applying the test of the significance, we first set up a hypothesis. A hypothesis is a defined statement about the population parameter. So, when you talk about the hypothesis, when we talk about the assumptions, we have to talk both the parts, the positive part of the inference as well as negative part of the inference. The positive part says there is no difference between the sample taken and the population concerned, whereas the negative part says there is a difference between the sample concerned and the population concerned. Okay. So, first of all, we set up a null hypothesis. We are going to talk about only two values, that is 0 and 1. 0 means no difference and 1 means there is a difference. So, 0 difference stands for null hypothesis and 1 difference stands for alternative hypothesis. So, such a hypothesis which is usually a hypothesis of no difference is called null. Null stands for 0 and 0 stands for no difference. Is called null hypothesis and is usually denoted by H0. Then, for example, in case of a single statistic, H0 will be that the sample statistic does not differ significantly from the hypothetical parameter value. We were discussing in the previous session what is meant by statistic and what is meant by parameter. Parameter is a measure of the population, whereas statistic is a measure calculated from the sample values. We set up the H0 as there is no difference between the sample statistic and the hypothetical parameter value. When you take two different samples from the two different populations, then we talk about case of two statistics, and in that case H0 will be the sample statistics do not differ significantly. Having set up the null hypothesis, next we have to compute the probability P that the deviation between the observed sample statistic and hypothetical parameter value might have occurred due to fluctuation of sampling. So, if the deviation comes out to be significant as measured by a test of significance, null hypothesis is refused or rejected at the particular level of significance adopted, and if the deviation is not significant, null hypothesis may be retained at that level. This is what is basic procedure of test of significance. We will be dealing with the detailed process of testing of significance later. So, what is about accepting and rejecting null hypothesis means when significant difference comes out to be more, then null hypothesis is rejected, and if the deviation significant difference is less, then null hypothesis may be retained or it may be accepted. So, when you are talking about the topic of null hypothesis, we have discussed how the null hypothesis is set up and how it plays a role in accepting or rejecting the population parameter. Okay. So, whenever we set up a positive part, there is also a negative part that is called alternative hypothesis. That is another part of the hypothesis concerned, that is alternative hypothesis. Any hypothesis which is complementary to the null hypothesis is called an alternative hypothesis, usually denoted by H1. Just recall, we have set up the null hypothesis as no difference between the sample statistic and hypothetical parameter value. So, its alternative will be there is a difference between sample statistic and hypothetical parameter value. So, for example, if we want to test the null hypothesis that population has a specified mean mu naught, say H naught is such that mu is equal to mu naught, then the alternative hypothesis will be H1 such that mu is not equal to mu naught. Okay, that is the exact alternative to null hypothesis. So, when mu is not equal to mu naught, there are two possible values. One is mu is greater than mu naught and another one is mu is less than mu naught. Okay. So, there are two possibilities and when mu is not equal to mu naught. In this case, it is known as a two-tailed alternative hypothesis. Setting of alternative hypothesis is very important because it determines whether the test of significance concerned is one-tailed or two-tailed. Now, the one case where H1 is such that mu not equal to mu naught, you have two possibilities, mu greater than mu naught and mu less than mu naught, and the alternative is called two-tailed. Therefore, the test of significance concerned is also two-tailed. Okay. And there is also another possibility when H naught is such that mu is equal to mu naught. Equal to mu naught, you have three possibilities, right? When is mu not equal to mu naught, mu can be only greater than mu naught and mu can be only less than mu naught. All these three are exactly alternative to mu is equal to mu naught. So, there are three possibilities. The first possibility we have talked is two-tailed, whereas the second and third one where such that H1 is such that mu greater than mu naught alone, where mu less than mu naught is ruled out here, specifies only one-tailed alternative. In that case, the test of significance is called one-tailed test. Similarly, H1 such that mu less than mu naught is also one-tailed, where mu greater than mu naught is ruled out here and we have only one possibility, H1 such that mu is less than mu naught, and it is also one-tailed alternative, and hence the test of significance concerned is one-tailed test. So, that is what is discussed here. The alternative hypothesis in 1 is known as a two-tailed alternative, and the alternatives in 2 and 3 are known as right-tailed and left-tailed alternatives respectively. This particular second one, mu greater than mu naught, is called right-tailed test and right-tailed alternative, and H1 such that mu less than mu naught is a left-tailed alternative. As I was discussing, the setting of alternative hypothesis is very important since it enables us to decide whether we have to use a single-tailed right or left-tailed or two-tailed test. Okay. After studying about the terminology hypothesis, next we step into studying the terminology errors in sampling. The sampling is done by random process. So, definitely there is a chance of error because no one is 100% correct and there is always a possibility of error. What kind of errors is possible in sampling theory? That is, the main objective in sampling theory is to draw valid inference about the population parameters on the basis of the sample results, where the sampling is done on randomization process. In practice, we decide to accept or reject the lot after examining a sample from it. This accepting or rejecting the lot after examining a sample from it is decided by the test of significance we are concerned. As such, we are liable to commit the following two types of errors. What are the two types of errors? Type 1 error says rejecting H naught when it is true. Is it not an error? Rejecting H naught when it is true is definitely an error. When it is true, it should be accepted. So, when it is rejected, that it is called a type 1 error. It is like when you are examining an items in an industry, the defective item is taken into account and the good ones are rejected. Good ones are rejected is called type 1 error. Okay. Type 2 error is accepting H naught when it is wrong. It is like accepting the defective item when you are examining the items in an industry. So, there are two types of errors. One is rejecting H naught when it is true, and type 2 error says accepting H naught when it is wrong. That is, we are talking about the hypothesis, right? So, accepting H naught when it is wrong, it means when you are accepting H naught, it means you are rejecting H1, because H naught and H1 are complementary to each other. Okay. So, that is accepting H naught when H1 is true, and the probabilities of rejecting H naught and accepting H naught has some values, that is called alpha and beta. Probability of rejecting H naught when it is true, that is probability of reject H naught such that H naught is true, is equal to alpha, and probability of accepting H naught when it is wrong, that is probability of accepting H naught when H1 is true, is denoted as beta. This alpha and beta are called the sizes of type 1 error and type 2 error respectively. So, in practice, type 1 error amounts to rejecting a lot when it is good, and type 2 error may be regarded as accepting the lot when it is bad. And we have discussed probability of type 1 error is alpha and probability of type 2 error is beta. This alpha and beta refer to producer's risk and consumer's risk respectively. How alpha is called producer's risk? You are rejecting the lot, you being the consumer, and you are rejecting the lot it is when it is good. So, it goes back to the producer. So, now it is in the court of the producer, therefore, it is called producer's risk. You being the consumer, you are accepting the lot when it is bad, you being the consumer. So, it comes to you, the lot comes to you, therefore, it is called consumer's risk. When it goes back to the producer, it is called producer's risk, and when it comes to you as consumer, then it is called consumer's risk respectively. And this tabular column tells you where the type 1 and type 2 error occurs and where is the correct decision. That is, accepting H naught when H naught is true is called correct decision, and accepting H naught when it is false is called type 2 error. Rejecting H naught when H naught is true is type 1 error, and reject H naught when H naught is false is correct decision. Continuing with the discussion about the terminologies in test of significance, the next terminology is critical region. A region corresponding to a statistic T in the sample space S, which amounts to the rejection of H naught, is termed as critical region or region of rejection. That is, when you are talking about the type 1 and type 2 error, it means it is probability of T belonging to omega where H naught is true is equal to alpha, and probability of T belonging to omega bar means it H naught is accepted, and when H1 is true is equal to beta. where omega union omega bar is yes and omega intersection omega bar is a null set. If omega is a critical region and if t is equal to t of x1, x2 etc. up to xn is the value of the statistic based on a random sample of size n, then probability of t belonging to omega where h0 is true is alpha and t belonging to omega bar such that h1 is true is equal to beta, where omega bar is the complementary set of omega is called the acceptance region. We talked about the critical region and this particular region where critical region is rejected is called acceptance region. Next terminology is level of significance. Whenever you draw an inference about the population, we are not 100% sure. That kind of discussion we have done in the previous session when we are dealing with the sampling distribution, because 100% inspection is also not possible because of the population is infinite and it is not possible in some of the cases. Therefore, 100% assurance is not given for the inference drawn from the population, because we are doing the sample on randomization. Errors may occur and there are errors, two types of errors we have discussed. So, when 100% is not assured, we may say sometimes we are 95% confident about the result we have got. So, when you are talking about 95% confidence, that remaining 5% you are leaving it for risk, that is you are not sure about the result. It means that remaining 5% is called the difference level of significance. Okay. When we are talking statistically, the probability alpha that a random value of the statistic belongs to the critical region is known as a level of significance. But we talked about the level of critical region as the probability of a probability of rejecting H0 when H0 is true as alpha. Therefore, the level of significance is the size of the type 1 error. Size of the type 1 error is nothing but maximum produces risk. So, the levels of significance is always fixed in advance before collecting the sample information. That is, whatever the information you are collecting, that you must be specifying that you are going to be confident only this percentage of level. Okay. That is, you are going to be only 95% confidence means that 5% level of significance is fixed as risk level. Okay. So, level of significance is called also called as risk level, and there are 3 standard risk levels being tabulated, that is one is 5%, another one is 1% and another one is 10%. One-tailed and two-tailed test, this we have already discussed in alternative hypothesis. When the alternative hypothesis is one-tailed, the corresponding test is called one-tailed test, and when the alternative hypothesis is two-tailed, it is called two-tailed test. In any test, the critical region is represented by a portion of the area under the probability curve of the sampling distribution of the test statistic. A test statistical hypothesis where the alternative hypothesis is one-tailed. One-tailed in the sense right-tailed or left-tailed is called a one-tailed test. And for example, a test for testing the mean of a population H0 such that mu is equal to mu naught against the alternative hypothesis H1 mu greater than mu naught is right-tailed, or H1 mu less than mu naught left-tailed is called a single-tailed test. In the right-tailed test, the critical region lies entirely in the right tail of sampling distribution of mu, while for the left-tailed test the critical region lies entirely in the left tail of the distribution. So, a test of statistical hypothesis where the alternative hypothesis is two-tailed such as H0 mu is equal to mu naught against the alternative hypothesis H1 such that mu not equal to mu naught, where mu is greater than mu naught and mu less than mu naught, both are possible in some cases, is known as a two-tailed test, and in such a case the critical region is given by the portion of the area lying in both tails of the probability curve of the test statistic. Let me draw the normal distribution curve for one-tailed test and two-tailed test. And this kind of normal probability curve you have already seen. This is rejection region alpha, and this is called right-tailed test, and level of significance here is alpha. What about left-tailed test? Left-tailed test is you have to shade it on the left. This is rejection region alpha. This is left-tailed test. Here also the level of significance is alpha. Okay. And this particular value is Z alpha, and here this particular value is minus Z alpha. Whereas in two-tailed test, both the sides are shaded. This is minus Z alpha. This particular part always stands for Z is equal to 0, and this particular part is Z is equal to alpha. Okay. So, this is called a lower critical value, and this is rejection region. Here the rejection region is being divided into two parts. One is alpha by 2 on left and alpha by 2 on right side. This particular value here is called upper critical value. Okay, and this is two-tailed test. Level of significance here also is alpha. So, in a particular problem, whether one-tailed or two-tailed test is to be applied depends entirely on the nature of the alternative hypothesis. If the alternative hypothesis is two-tailed, we apply two-tailed test, and if alternative hypothesis is one-tailed, we apply one-tailed test. For example, suppose that there are two population brands of bulbs, one manufactured by standard process with mean life mu1, and the other manufactured by some new technique with mean life mu2. And if we want to test if the bulbs differ significantly, then our null hypothesis is H0 such that mu1 is equal to mu2. Mu1 is equal to mu2 means the bulbs produced by standard process is actually mu1, and the bulbs produced by the new technique is mu2. There is no difference between the standard process and new process. This is what is H0. What is the alternative hypothesis will be H1 such that mu1 not equal to mu2, thus giving us a two-tailed test. Actually, we are discussing an example for two-tailed and one-tailed test. However, if we want to test if the bulbs produced by the new process is better, then we have H0 mu1 is equal to mu2, H1 will be mu1 is less than mu2, that is mu1 is standard process, mu2 is new process. We are going to test if the new process is better, that is H1 is such that mu2 is greater than mu1. Better means it is going to give the bulbs produced by the new process will give more life than the mean life of the bulbs produced by the standard process. So, H1 is such that mu2 is greater than mu1, or you can write it in this format of mu1 and mu2, mu1 is less than mu2. This particular H1 such that mu1 is less than mu2 mentions this is going to be a left-tailed test. Okay. we cannot decide H1 on mu2 greater than mu1 as a right tail. That is wrong. It should be converted as mu1 is less than mu2. Therefore, this particular test is called left-tailed test. Similarly, for testing the product of new process is inferior, we will have H1 as mu1 is greater than mu2, thus giving us a right-tailed test. Thus, a decision about applying a two-tailed test or a single-tailed test will depend on the problem under study. Now, continuing with the discussion about terminologies in test of significance. Next terminology is critical values or significant values. That is, this is the calculation part and the most important part of test of significance. The value of test of statistics which separates the critical region and acceptance regions is called critical value, and it depends on the level of significance used and the alternative hypothesis whether it is two-tailed or single-tailed. As been pointed out earlier, for large samples the standard variable corresponding to the statistic will be Z alpha, and the value of Z alpha is equal to t minus E of t by standard error of t. The value of Z given by this star under the null hypothesis is known as test statistic. In this session, for discussing about the test of significance, some terminologies are required. We are going to take up a case and we are going to test the significance of the sample statistic and population parameter. Therefore, before testing the significance, some terminologies should be understood. That is, the terminologies like hypothesis, critical region, level of significance, errors in sampling, that is type 1 and type 2 error, tailed test, that is one tailed test and two tailed test, etc., was discussed in this session. Based on this discussion in this session, the following questions may be posed. What is meant by test of significance? Define null hypothesis and alternative hypothesis. Mention two types of errors. Define level of significance. Thank you.